Hey everybody, do a quick video today. This is something I'll dig into a bit more of how I have this set up, but I figure we'll start with kind of the interaction and the developer experience that I was going for this. This is just an integration of some existing technologies, but I think it enables a nice developer experience, so let's go over it quickly. The first thing I'm working with is the Almond Shell, or the Scala Jupyter kernel, which is really nice. It installed really easily in my environment and has worked quite well. I'll go over later how I installed it in my environment, because my setup is a bit different from usual. In particular, I'm running Jupyter on a dedicated server with shared access for everybody who has access to that server. So they all see this interface here, and they can, see whatever notebooks you want to do. And this is nice for its shareability, but I'm not a huge fan of inline development in Jupyter. I think it's good for integration, doing scripts essentially, but not actually coding anything legitimate, like a legitimate library or such. I really like developing libraries and then pulling them into Jupyter for exploration. And here we can see the classic MNIST deep learning demo, but this is using Scala instead of Python, and it's using the Platin iOS, or however you say these guys, TensorFlow binding. And we can see this is actually all cached, but we will just restart and run all cells, and hopefully this will work. And indeed, we see it start chunking its way through just fine, just exactly how you would expect when using Python. The images are displayed, just everything works really well. I'm very impressed with this Almond kernel. It was easier for me to get running in my environment than the Python one, actually, and we'll go over that later. So this is pretty the standard development interaction. I'm sure a lot of you are used to, where you have your Scala Jupyter kernel running, and you're able to interact with it like this. But like I said, this is a shared notebook interface, but I like to have the developers be able to add libraries that are accessible to this notebook. So those developers can develop those libraries on their own and then pull them into the notebook to share explorations. And there's a bit of trickery to get that to work out with this configuration. I'm not using something like Maven Central for a repository. I'm just using a local directory repository. I had a few false starts getting this working, but eventually got a setup working fine. So we're going to close this, because we're actually going to talk about what it looks like for one of these notebooks that's pulling in a library, and what is the special magic essentially needed to get this to work. And that we see right here. What we're looking at is the instructions to Ammonite, because Almond is built off of Ammonite, to tell Ammonite to add a repository for the developer. And in this case, I'm referencing my local Ivy repository, and then telling Ammonite to load in a library from that. I'm not an expert in Ivy, so this took a bit of trying and experimentation to get working, but this ends up working just fine. And we can see we can run this, and we'll just restart everything. It imports the library just fine, and then it runs this little sample chunk of code, and we see this is outputting where. So this is nice from exploration, and developer can develop the library on their own using their standard IDE, such as, in my case, Emacs plus Metals, and then share it with everybody else under a Jupyter kernel. So let's see what that looks like to develop this library. Here we're looking at the build.sbt for that. And there's nothing really special about the build.sbt for developing such a library. It really is this chunk here that is the necessity for importing a particular developer's local Ivy repository nicely. The key bit, though, is to make sure you're using a snapshot revision. By using snapshot sbt/iv, I really don't know which one, we'll check for changes every single time. The other key is to make sure you're using Scala 2.12.10. Last I checked, the directions say 12.8, but that won't work. You'll end up with an odd error, so use 12.10. And here you see I've imported the Planetaios TensorFlow bindings, and the rest of this, aside from those two critical details, is pretty standard. And from a developer perspective, what I can do is I can do publish local, and it will publish the updated library to my local repository, which on restart of this kernel, it will reload that particular dependency. You have to do a reload, otherwise it caches this information in the interpreter, and changes here won't actually have an effect, and you might get some strange errors. So always try, if you're getting some strange errors on loading this in, do a full restart of the kernel. So with this setup, I can set up something like this. I can set up a watch that triggers publish local in this library's SPT session. This means it's going to be watching the source code and publishing it every time the source code changes. It will also compile it, of course. So we have here a simple package object where I'm going to collect some stuff related to the exploration I'm doing. And we see that we do have our metals support working fantastic. As always, we can do our very nice autocompletes for imports. Which is great. I know the Almond Shell has a degree of autocomplete, which is great for exploration, but when I'm doing development, I really want this full autocomplete experience. So we have our nice autocomplete experience with metals and Emacs, our standard IDE. We have our dependencies pulled into this library. I don't have to pull them in here because, of course, those transitive dependencies are going to get pulled in as part of this. So we can go ahead and change something here. I'm just going to change that to when. I'm going to save this. And we'll note SB2 is doing what it does quite well, which is it's triggering a new build based off of that change, recompiling it, and then republishing that library to my local Ivy repository. And now we find that we can just restart our kernel in Jupyter. It's going to reload that library. And then it's going to re-execute this, and now we have our changes. I think this setup is really effective for getting the best of both worlds. You can develop your library, your software as a reusable library using your IDE of choice, and fairly easily reload it into your Jupyter notebook for exploration and sharing with your teammates. This particular version or setup does rely on using a shared server. In our case, that's fine. We have a beefy shared server with accelerators and such that is running this. If you were to not have a shared server, you probably want to use something like a HTTP repository, but I find that a bit more trouble than this is. So really, this has worked really well for us. I'll dig into more how this is set up. This is actually set up on NixOS, this Jupyter deployment, and it does have Python support, acceleration support, and everything like that. And that is something given that it is a NixOS module, can be packaged up and you can install yourself. I will go over that later, though. For now, I just wanted to give you a preview of some of the setup I'm going to be talking about and the developer experience involved in that. And hopefully, if this is useful for you, stay tuned and we'll dig into it a bit deeper. Until then.